All right, we're looking at another algebraic method of solving quadratics. And don't forget, when you are solving quadratics, what key feature are you finding? The roots, which are also what?
The x-intercept.
X-intercepts are zeros. Very good. All right, so we're going to use this method to find those zeros. But guess what? You can also use this method for. You can use it to convert standard form quadratics into vertex form. Multiply out these binomials. These are squared binomials. Do we distribute the power inside?
No.
Say it louder.
No.
Thank you. These should all make perfect square trinomials. Whenever you have a binomial factor, like we have all here, these are all binomial factors, being squared will always create a perfect square trinomial. So we know all the first terms will be x squared. And we saw that if we add the number, the constant in the factor, like 1, add it to itself, 1 plus 1 is 2, 2x. And then you square it, or multiply 1 times itself, you get 1. Let's see if that holds true all the way down. So next one is 2 plus 2. What's another way to say that?
2 squared.
No, that'd be 2.
Never mind.
2 plus 2. It actually is true in this only one case. All right, let's keep going then. 2 plus 2 is 4. And then 2 times 2 is 4. Okay, let's go to the next one here. 3 plus 3 is 6. So is there another way to say that? 3 times 2. Neat. 3 times 2. Okay. And then we square it, we get 9. Okay, or if we double the constant, double means times it by 2 or add to itself, what do I get? 8. And then what do I do with my last term? And get what? 16. So we get 8, double it, and then multiply by itself. Double the 5, get 10x, and then multiply 5 times itself to get 25. Now your task to do is find another pattern. Okay, and this pattern is going to, I want to see if there's a pattern going from the middle to the last term. Is there a pattern going from the middle term to the last term? Is there a way to build the last term if you knew the middle term? Is there a pattern? So a pattern we saw and said was take the middle number. So middle number, and then do what to it? Divide it by 2, and then square. Let's see if this is true. All right, so the middle number here is 2. What's 2 divided by 2?
1.
And 1 squared is?
1.
Okay. What's 4 divided by 2? 2 squared is?
4.
Uh-oh, I think it's going to work. Skip a couple here. What about 8? 8 divided by 2 is 4, and 4 squared is 16. I think Vincent cracked the code here. It's the middle number divided by 2, and then you square it, times it by itself. That makes sense, though. All right, let's come up with a kind of a formula or a symbolic form of this pattern. So what coefficient represents the middle number?
B.
B. Okay. So B, this means this is our B value. The middle number is the B value. All right, let's do the symbolic form down here. So take B and do what to it? Divide by 2. How can I do that symbolically? How does that look?
Fraction.
Good, good. Fractions B over 2. B over 2. And after I divide it by 2, I do what? Square it. So I just put a square right there. Parentheses. I have to divide first and then square it. So it's going to go divide first, b divided by 2, and then square it. This is what we're going to use to complete the square. So completing the square is going to help us build things that are perfect square trinomials. So we're going to take something that's not factorable and make it factorable by building a perfect square trinomial through this process. So we're going to practice that on a simple little expression here. If I had x squared plus 16x What's going to have to go in this box to make this a perfect square trinomial? So you're building perfect square trinomials. 64. Yeah, you're right. You're right, 64. Because we take the middle number, 16, and we divide it by 2. What do we get? 8. And what is 8 squared? 64. And we're going to add that there. Will we ever be adding a negative number? No, why not? If you're squaring, it turns positive. A negative times a negative will be positive. It will always be adding a perfect square there. All right, there's a pattern 1 practice. Go. You should have this done in about, right about now. All right, we think it's 121. Let's go ahead and make sure it's right. Again, take the middle number, negative 22, divided by 2, I get negative 11. Squared negative 11, we get what? 121. Hey, now that we've built these perfect square trinomials, go ahead and factor them. Don't forget, we are building perfect square trinomials. These will always factor the same way. It looked like this up here originally, our first example. So when we go down here to factor this perfect square trinomial, help me out. What sign will it be in the middle? Plus, because a plus right there. So plus. And what times itself is 64? 8. So x plus 8 squared is the factored form there. On the bottom, what will be my factored form? Good. Minus is a negative here. It's got to be negative in the middle here. And get 11 there to get 121. Okay. All right, before I tell you when to use this method, we're going to see some problems and use it. And I think you'll be able to determine when it's going to be a headache of a method. All right. So let's do some examples. Let me zoom in. All right, before we do practice our new method, I want you to go ahead and use one of your old methods of how to solve a quadratic. What are some of the ways you've learned how to solve a quadratic or find the roots of the x-intercepts? What's the very first one you learned? Graphing or a table. Identify the roots from a graph or a table. And then we looked at an algebraic way to do it, which would be the factored form or factoring, solved by factoring. And yesterday, what did we do? Square roots. So you have those options to solve this quadratic. Go. All right, so we looked at trying to factor this, and a lot of you say this is unfactorable, and you are completely correct. Write that down, though. This is unfactorable. But remember, if it's unfactorable, that does not mean it's not no solution. Doesn't mean it doesn't have any roots. It's just you can't use factoring to find the roots. We're going to learn that if you can't factor and it does have real roots, then that means they're irrational roots. So we have to use another method. Okay, do you want to graph it? No, because even if you do graph this thing, it's going to cross between some whole numbers where you won't be able to see the actual precise value of the root. You have to use another algebraic method, and that today is complete the square. All right, our first step, when we can't factor, we're going to move the constant over, get the variables by themselves. All right, get the variables to one side, leaving x squared positive. Now, this is only going to work when a is 1. I just gave one of those. Bummer. All right, so we're going to move that 4 over. We're going to add 4 to both sides. So that's going to leave our variables over here, x squared plus 4x equals 4. So that's step 1. All right, so again, we were able to factor the original, so we're going to make it factorable by making, or building, I should say, a perfect square trinomial. First way to do that is to add a blank square to both sides. All right, so don't forget, this is a common mistake in complete the square, is adding that square on both sides. You have to be balanced in math and in life. Okay, so now what goes in the box, remember, to complete the square, we're taking the middle number, the b, coefficient, we're dividing it by 2, and we're taking that quotient, and squaring it. So b divided by 2 and square it. That's going to go inside the square. So 4 is the middle number here. So 4 divided by 2 is 2. And then you square it. What do you get? 4. That's going to go in this left box. And don't forget the right-hand side. 4 and 4 go there and there. What do you think the next step is? Factor. All right, now, like you said, the next step is to factor and simplify. So that was our step 3 there. We completed the square. Now we're going to factor the perfect square trinomial that we made up here. Okay, so it's going to always factor to be a binomial squared because we built a perfect square trinomial. So inside we'll have x. And what's our constant for this one? Plus 2. We take the middle sign, positive, and we take the square root of the last term here to get that 2. So plus 2, and that's the binomial squared. Now the right-hand side can simplify to equal what? 8, that's right. Let me get these color. There we go. And we get 8, again, by adding 4 plus 4.
Oh, and then do you subtract 2?
Get 8. Nope. We need to undo the binomial square using what we did yesterday. Square roots. So this is what we learned yesterday. Now it becomes a problem just like yesterday. We're going to undo the square here by taking square roots of both sides. That's step 5. All right. Now we're going to break free the x plus 2 by taking square roots. Okay, I'm going to take the square root of that binomial being squared. So x plus 2 squared. And I'm breaking free that binomial inside. So just x plus 2 comes out. But I got to do square root on both sides. So on the right-hand side, when I take the square root of a number, I have to remember what?
It's positive.
Positive or negative. The principal or the evil twin roots. All right, now I have x plus 2 equals plus or minus root 8. Is there anything I could do to the square root of 8? Very good. How do I simplify it, Jaylene? 4 and 2. So, very good. So 2 breaks out. So we could rewrite this still with the plus and minus, but the simplified version of root 8 is 2 root 2. We are one step away from our final answer. Subtract 2 from both sides. I'm going to keep that blue actually. Yes.
What's the one above this?
All right, now we move the 2 over here by subtracting. But here's a common mistake again students will make. Is they think that they could add and subtract these 2 terms. Can you combine these 2 terms?
No.
No. Why not?
Because
One has a radical and the other doesn't. One's rational and the other one's not. So my final answer should look like this. The negative 2 that came over in front of plus or minus the irrational part, 2 root 2. When you have a square root that you cannot evaluate, get a whole number from, do not round it for decimals. That is your answer. Right there. Now, did I lie to you? I said there was 2 roots, but we only have one answer. Or are there 2 answers there?
There's 2 answers.
Don't forget the 2 answers are represented by what symbol?
Plus and minus.
Plus and minus. I'm going to just go ahead and add that in here. So you don't forget there are 2 roots. Because that gets lost in this procedure. One of them is negative 2 plus 2 root 2. And the other one is negative 2 minus 2 root 2. Okay, those are your x-intercept values. So if you really want to write the x-intercept, get crazy. Comma 0, comma 0. Those represent the x-intercepts. So if we look at a graph, we're going to see them cross, the parabola cross at those 2 irrational values. So that one on the left there, on the calculator, we could approximate this to see where it would look like on the graph. It's about 0.83, comma 0. So if we graphed it, we should see it cross between 0 and 1. The other one there, let's see. And this other one is about negative 4.83, comma 0. Now, we only do this to see where it would cross on a graph. It'd be really useful in something like in context. Say like a projectile object falls on the ground. Which one would be the valid answer? Which root would be the valid answer? Would it be 0.83 or would it be negative 4.83? Gotta be the positive root, right? So you say, oh, it's about 1 second almost. About 0.8 seconds. You don't say time in, hey, about negative 2 plus 2 root 2 seconds. It falls. So this is when we use approximation when we have context. Otherwise, leave it in this radical form. All right, now that we've seen a few examples, let's go move back up here and answer this question. Okay, so the complete the square method will work on any quadratic function. Okay, but it will be more messy or more of a headache on certain types. So you only want to use this method when these two criteria are true. You want to make sure that first term, the lead coefficients, a, you want to make sure a is equal to 1. If it's not equal to 1, you would have to do extra work, which means it's not the method for this problem. All right, you also want to make sure that the middle term, since we're dividing by 2, you want to make sure the middle number is even. The middle number, or the b value, is even. If it's odd, it will always create fractions that you'll have to square and add both sides. So it's always better to use another method when this happens. So when a is not 1 and the b is not even, don't use this method. Use something else. All right, look at this problem. I can't factor this. No factors of 16 will add up to negative 12. So I'm stuck with complete the square. I'm going to move the 16 over, subtract 16 from both sides. Leaves me x squared minus 12x. I'm going to go ahead and put in a blank square here because that's what I'm going to be completing in a second. So over here I have negative 16 when I subtract it over. Where's my red? There it is. Negative 16. And another blank square I'm going to fill out. So how do I fill that out? I take the middle number and divide it by 2. Middle number is negative 12. So negative 12 divided by 2 is negative 6. Now you square it. What do I get? 36. It's going to go into that box and that box. So add 36 to both sides. Not changing the value of the equation. It's balanced. Now we made a perfect square trinomial that we could factor. So we're going to factor it to be a binomial squared. Okay, take the middle sign, negative 12, so negative, and then we either take half of 12 or think about what goes right here is what goes right there. So minus 6. All right. On the right-hand side, we take negative 16 and we add 36, and we get 20. Now it becomes a square root problem. I'm going to take the square root of both sides, and that breaks out the x minus 6, and it equals, now this is a positive or negative root 20 that we could simplify with the square root of 4 and 5. Root 4 becomes 2 on the outside, so we'd have plus or minus 2 root 5. My last step is to add 6. I can't add 6 to that 2 there, so it's going to be separate from it. So my answer will be x equals that positive 6 plus or minus 2 root 5. Okay, it's irrational, so we're going to keep it in radical form. Those are my 2 roots. Thank you. May the math be with you.